Hey guys, welcome back. So today we are revisiting the recent upgrade we did to the load bank. We went from a 10 kilowatt capacity and we added these two space heaters, and now we can theoretically pull 20 kilowatts. We recently tried on a 20 kilowatt machine and we fell short. I think some of that may have been fuel delivery. Potentially there were issues with that machine. So I am going to revisit that at some point. But for now, I wanted to do a few more things to this load bank. There were a lot of good comments and suggestions, some of which I want to implement now. So yeah, let me get you set up a little bit better and get going on this. So there are a couple things in here I want to tackle. I guess first off, this breaker for the load bank, it is a 60 amp breaker and it only needs to be a 50 amp. But at the time, the store was out of 50 amp breakers. But I went back today and I was able to pick up a 50 amp breaker. So swapping that out should be easy enough. The thing that's going to be a little bit more complicated is that I do want to split the grounds and neutrals. With the configuration I have now, it should be fine for testing standbys. But if I ever come across a scenario where I need a unbonded system, I can't do it with the way that it's set up right now. So I did also pick up the proper grounding bar, which installs over here. And that kind of presents us with the next issue because the space here is a lot tighter than over here. So getting all the wires where they need to be could be a challenge, and at least one of them I know is too short. It's not going to make it over here. So we're going to have a little bit of work to do, and I say we start there. So I'm going to pull these breakers out just to give us some more space and remove some of these zip ties. We'll get that bus bar installed for the ground and then finish it up with the 50 amp breaker. So I'm just going to get the wires disconnected. Actually, let's just pull the breaker out and then disconnect the wires. And I've got to say, it does feel wrong to be doing this. We just got it together, just tested it. But I do want to make it the best that it can be within reason. And I did get a lot of comments too on these little fuses I installed here. So just to clarify, these are not on the CTs. The CTs do not have a fuse, but the power source for the meters do. I thought feeding power from a 20 amp breaker to those little cheap meters may not have been very safe. So that's what these fuses are for. And I'm going to try to keep all these ground wires at the length they are, which I know is going to make a little bit of a mess in here, but if I shorten these wires and then in the future need to put things back, which I which I doubt, but I'd rather have a little extra wire here than not enough. So we've got 3 moved over without a whole lot of issue. You know, it actually went in there pretty neat. We have 1 left going up to the plug for the load bank. So that has to be moved over, but it is too short. So I'm going to cut up and install a fresh wire for that. And then that just leaves us with the big one coming in from the cord, which connects to the generator. So that one is definitely long enough, but we're going to save that one for last. And we're going to cut this longer than we need. And we'll make the final cuts later. So once this is cut, I'm going to pull the cord back out. We'll strip the sleeve off, get the ferrules installed, and finalize this plug and all the grounding. And we're going to fish this over. And I'm going to hook it up, as low as I can. Again, I'm trying to keep these wires long just in case in the future things need to be moved again. So the length actually looks to be pretty good. Let's see how far down it's going to go. And haven't quite decided what to do. I did pick up this lug to accommodate the 4-gauge wire, and it adapts it into the ground bus bar. The issue is we have all these ground wires in the way. So, yeah, that is a problem. And it's not going to fit on the other side because not enough room. So if I can flatten these wires out, well, I was going to say maybe that'll help, but I don't think it will. So I think what I'm going to do here is not use the lug that I got. There's just no way to fit it in there. It's too tight. So what I'm going to do is cut this off. And I'm thinking, we could strip this back, get 2 bunches of wire and 2 ferrules, and then attach it to that bonding bus bar. It doesn't really matter if we have too much metal and it touches, because that's the whole point of this. As long as we're not touching, like the live wires, we'll be fine. So yeah, let's strip that back. I would say at least an inch, maybe a little more. And then we'll put 2 ferrules on it. All right, that should be decent. We'll do another ferrule. I did remove the insulator just to give us a little bit more flexibility to make the bend. So we want this one to be right about there. And again, because this is ground, we don't need the insulator. This is supposed to be connected to all the metal, which is why we can get away with this. think that'll do. And that 4-gauge wire was surprisingly difficult. So I used 8-gauge ferrules, and they really did not want to go in there, but I did manage to get them in. They are secured, and that arguably is probably one of the most important ground wires to have in place. You know, that is the feed from the generator, so we want to make sure that is in there good, and it is. So let's finish up the load bank wiring. We got to connect the neutral, get the breaker back in for pretty much all that were pulled, and we'll just neaten things up and we'll be done in here. And actually, while we're in here, I do have red shrink tubing, which I didn't have at the time we did this, at least not the right size, but I think I have what's needed now. So we're going to go in here with the 50 amp to feed the load bank. We just need to get this in to size up where to cut the wires. Okay, so theoretically it's done, besides zip tying everything back in and tucking it away safely, but let's just test it real quick. I'm just going to use the multimeter to test continuity, and with the way it's configured right now, there should still be a bond between neutral and ground. And there is, but if I remove that green screw in the top corner, that bond should go away. So let's try it. All right, the screw is removed. Let's test it again from neutral to ground. And yeah, we get nothing. So that dramatically simplifies things if we need to test a generator that is bonded. And if we wanted to get really fancy, we could actually remove this screw altogether and run a wire between the ground bus bar and the neutral and put, a high amperage rating switch, and we could just toggle it from outside the box, to bond it or to unbond it. But in this case, it's now super easy. We just have to remove that bonding screw and the system will be floating. All right, one last look at the box before we close it up. So now the reds are on the top breaker of the double breakers, and that corresponds with the red coming in from the generator. So, everything has been zip tied and secured. So all we need to do is get the cover back on. So now that it's done, we have the neutrals and the grounds on separate bus bars, and we can easily bond or unbond the panel as needed. So we're going to move on to the space heaters. There is one big thing, actually safety related, that we need to deal with. When torquing down the wires, I actually broke a bit, and a piece of that bit, I believe, is still in the heater on the right. So we're going to open that up, see if it's still there, and pull it out. And while we're in there, we're going to make some wiring enhancements, or at least investigate, can we do it? The first one being the fan control. These fans turn off instantly when you turn the heating element off, which technically is fine, but I'd actually prefer to keep the fans running at all times. So we'll make that modification. And then the other thing to look at is the thermostat itself. According to the manufacturer, in the max setting, it's going to turn off at 95 degrees, which on some hot summer days, that could be an issue. So if we can bypass that and still keep this as an on-off switch, then we'll do that as well. So we're just going to pull out these screws if possible and drop the bottom pan and see if that piece of metal is in there. Ultimately, I want to pull this heater out entirely and flip it upside down for the wiring modifications, but if the metal's on the bottom, I don't want that falling somewhere where we can't find it. I'm going to tilt this a bit to access the screw here on the side, both sides, and actually I heard that piece of metal just move, so I think it is still in the pan. Yep, there it is. There it is right there. Don't think it would have caused a problem, but you don't want metal debris floating around where there's electricity. So that is out. Let's take the heater off. We'll flip it upside down and make some modifications. And just following these fan wires, I think the modification is going to be pretty easy. We have one fan wire going right to leg 1 coming in, so that is unswitched. And then we have the other one coming over here to the overheat protection. So if we move that wire over to leg 2, then the fans will always be powered. As far as the thermostat goes on the front here, I'm not sure there's a lot we can do unless we replace this entirely. The way it's wired right now, we have leg 1 coming in to the thermostat right there. We also have leg 2 coming in right there. And presumably these are the outputs here. So one of them goes to the thermal protection. The other one goes right to, I assume, a heating element. And when it comes out of the thermal protection, looks like we have one wire going right to a heating element. And another one going into the selector right here. So based on the position, we're either going to run at 3,000 watts, 4,000 watts, or 5,000 watts. We have 2 wires coming out. Total of 3 wires going to the heating elements. So yeah, that stuff I think we're going to leave alone. For now, let's just modify the fan so that it continuously runs. So we'll just hold that fan wire off to the side and reconnect the remaining wires back to that safety. And all we need to do now is to connect this wire right here. So the ring terminal, it's not going to help us in this case. There are spade connectors though right there. So if we chop that off, add a spade, we should be able to plug that right in and finish the wiring. All right, that should do it. So I'm going to add a few zip ties back. And actually, before closing this up, I want to add a piece of red shrink tubing. I didn't have it at the time, so I just colored this with a Sharpie, but I think we can do a little better now. And now we can just reconnect this and close it up. But something unexpected happened. And I'm actually going to take this out of circuit and just set it off to the side because we need to make some more modifications, a little bit more than planned at the beginning of this video. And no, you are not seeing double, but this is kind of the unexpected complication. So this load bank here, it is identical to the one that I've been using for years. It actually appears to be in better condition and comes to us from a subscriber, Darren, who I recently did some work for. So as a thank you, he gave this to me. You know, he found it on his local Facebook marketplace. I think the seller was asking $800. Darren, I believe, lowballed him at about half that, and they said, come and get it. So he picked it up actually from a Camping World, which is an RV super center, and they use this, or they were supposed to use it to load test generators on RVs, but I don't think they actually did. So they just wanted it gone. So now that it's here, it's kind of changed the plan a little bit as far as what we're doing. You know, the wiring coming into this can't handle these two, which is 20 kilowatts in total, plus the two down there, which is another 10 kilowatts, bringing this up to 30 kilowatts. So I think what I'm going to do is eliminate one of the space heaters, likely this one right here. We'll keep the one we just modified. We'll wire this in, and then we'll have 25 kilowatts of load attached to the cart. But that definitely brings some complications because the tabletop, it is now too small. We're going to have to fix that. And also, we're going to have to redo some of the wiring. So before we do any of that, I do want to test this and just make sure it works properly. So I'm going to get a 50 amp cord installed. We'll get this thing powered up, try it out, and make sure it's good to go. Another thing I'm noticing too is that these switches, they should be straight up and down, but a lot of them are kind of sideways. So we'll correct that issue as well when we're in there. And yeah, this load bank, it does appear identical to the one that I've been using for the last couple of years. So, you know, aside from a bit of dust, everything seems in order. You know, on the back side, I think you can see the issue a little better with these toggle switches. These should be straight up and down. You can tell that one is severely tilted at an angle, and really all these are, so we need to straighten those out, maybe blow the dust out, and then we'll get the 50 amp cord installed, and we'll try this out. So we're going to start actually by straightening these switches out. So I'm just loosening the nut on the front side. And now we can move it into the correct position, clamp it down, and we'll just do that for the whole row. Can you please stop texting longer? All right, and this is the one that's missing the nut, so I'm going to add one. Then we'll torque it down. Okay. Yeah, I'm noticing this relay is sitting kind of cocked to the side, and the mechanism that holds it down doesn't seem to be hooked in properly on the far side. So don't know if that's related or not, but I do want to at least take the relay off and make sure we don't have any pin damage. And no, pins actually look fine. So let's get this hooked on properly. And it's not really going in all the way on the right, so I think that's part of the issue. Yeah, and it does plug in nice and flat, so I don't think we have an issue with the relay. It's most likely just an issue here with the hold down. Okay, now it's back in place, so I think that'll be good. So those are the main legs going in, leg 1, leg 2. We also have these auxiliary wires, black one on the top, blue one on the bottom. So we have a few zip ties we have to cut out of the way, but first let's get the ground and the neutral disconnected. And just note the wire that was connected on the top of the breaker, that goes through the current transformer, and it's actually looped around, so the wire goes through twice. And the neutral goes through another current transformer in the back, and it's just a straight shot. It's not looped through a second time. So this is the cord here we're going to use. It's a nice heavy 6-gauge cord. I think it's about 12 feet long, which should be more than enough. But we do need to strip some wire back. If we look at the wire we pulled out, you can see how much of that is stripped back. So we need to find the longest wire and then kind of backtrack to see where we need to strip to, which in this case looks to be right about there. Not quite there yet. So every time I turn that in, it's actually pushing the blade further down. You can see we're just starting to break through, so maybe just a little more. And we're just about there. Yeah, I think that'll be good enough. So then we just pull this down the length of the wire, and in theory it should cut it, making it easier to remove the jacket without damaging any wires. Yeah, it looks like it's full of powder. And there we go. So we're going to chop this ring terminal off. We need a larger 3/8 inner diameter terminal. And we're going to use the same stripper to remove the insulation, but we need to back it off since this is thinner insulation on this wire. So let's strip it back. There we go. And this is really a three-handed operation. You need to hold the wire in place until the crimp is started. So the floor works good to make this a two-hand operation. You just start the crimp, and once the wire is somewhat secured, you can let go and finish it off. And actually, before we crimp leg 1 and leg 2, We actually have that red and black wire that's kind of doubled in, so I'm thinking we'll do the ferrule once the wire is installed, and we'll slip the extra wires in before crimping it down. So it seems like we're going to be okay with the wire length. The red just makes it, so we're going to combine that with the black. And then the black live wire comes in, and it's going to connect down here on the bottom, doubled up with that blue. So yeah, let's make those final two connections. We'll add the ferrules, get everything connected, and then I think we can close this up. So the red wire, we already stripped back. We're going to do the same now to the black. And in close quarters, the blade works a lot better than the other tool. So we're going to remove the insulation. We'll get the ferrule connected as well as the other wires that need to go into that breaker. And that should do it. So all the switches, they've been straightened out. So has the relay, and the new 50 amp cord has been wired in. So let's get this closed up. We'll plug it in and try it out. All right, so let's give this a try. Get the master switch off as well as the fan control. And I've adapted the 50 amp cord we just connected down to 30 amps because that's what we have access to here in the garage. So with this connection, we can safely pull 7,200 watts. So let's plug it in. And things came alive. So we're showing just a touch over 60 hertz, close to 250 volts, probably about 248. Let's see if the fan control works. Yep, fans are on. Let's turn on a 2,000 watt load, but that will not apply until we turn the master on. So when we do that, we should see the amp gauge bump up a bit. And we do. Let's try 4,000 watts. Let's try a different element. 4,000 watts, no issues. Yeah, it's maintaining the 4,000 watts. Let's try 5,000, 5,500, 6,000. So that is perfect. It seems like all the heating elements are working. Fans are working. Obviously the master switch and the contactor are working. And this switch here just changes whether we're measuring the full 240 or just one of the legs. So if I switch this to 120, it should cut roughly in half, which it does. And interestingly enough, the amp gauge went to 0. So I guess that's not too much of a surprise since we have it wired for 240. But yeah, things seem to be working just fine. And I can actually smell a little bit of dust cooking off those heating elements. So let's turn these off. We'll go to 6,000 watts. And let's do 8,000 watts for a short time, just keeping in mind the cord isn't really rated for that. And yeah, no issues at all. So the new load bank seems to be ready for action. And while it's cooling down here, let's just check the accuracy of this gauge. I think it is a little bit high by a few volts. And yeah, we're at 245 volts. And when looking at the gauge, it looks closer to 248. I guess we can check the frequency as well. This is at 60 and a half. And the meter says pretty much 60 hertz. So yeah, the analog gauges, they aren't quite as precise as digital. But the one thing they have going for them is that they are very easy to read, especially when we're outside in the sunlight. So these, I think we're going to keep as is. And of course, when we test standbys, we do have some digital gauges that we can use just to get an exact reading. Anyway, got to give it a few more minutes to cool down, then we'll shut it down, and then we'll finish up this project. So I'm going to take a second, just clear the table of the load banks. We're also going to pull the last space heater. We need to remove this top, replace it with one that's slightly larger, and then we can finish up this project. All right, so I took a second, just made sure everything was centered up. I clamped it down. We are nice and flush here on the front. And I was going to drive a few screws up from the bottom to secure it. The issue is the screws that I have are a little bit too close for comfort. So ideally, I would get something a little bit shorter. So for now, I'm just going to use a couple brackets on each side to hold things in place. And a little bit later, I'll make a trip to the store, see if I can find something a little bit more appropriate, and we'll drive a few up from the bottom. Well, I jumped ahead just a bit and got that modified space heater reinstalled. So, I was just doing the final prep work to get this 50 amp outlet installed. I swapped out the 30 amp breaker that was driving that space heater for a 50 amp and also pulled the 10 gauge cord. And now we have 6 gauge hooked up to that 50 amp breaker. So really the last step was just to wire this in, bolt it somewhere on the cart and call it done. That said though, I kind of hate pulling the space heater off. Now, granted, we probably don't need 30 kilowatts of load, but the fact is we have this heater and I think we can potentially make use of it at some point in the future. So although we are maxed out in that breaker panel, I think the solution is actually right here. I am feeding this leg 1 and leg 2, so we do have access to 240 volts and we can send that right up to that space heater. So there will be some complications to this, but I don't think it's going to be a big deal. So let's get this reinstalled. It's already been modified like the other. And once this is in place, we'll complete the wiring to that heater and then finally the wiring to the second load bank. And it's not going to be just as easy as extending the wires to that space heater. There's a couple things we need to keep in mind here. I guess first off, these are GFCIs and they are expecting the current to return on the neutral, but at 240 volts that will not happen and these will immediately trip. So we do have to eliminate the GFCIs, which will actually solve another problem because this is the tamper-proof variety, and they actually make it quite hard to plug things in. So I got just some standard regular outlets that don't have any tamper resistance to them. So it should make this quite a bit easier to deal with. So let's get the outlets completely uninstalled. Disconnect the wiring and replace them with the new ones. And for this install on this type of a box, we need to break these little ears off. We also don't need to attach the grounding wire right to there because the ground is actually attached to the metal box, and it'll pick up the ground actually from the body here of the box itself. Alright, so we're going to start with leg 1, which in this case is the red wire. And I'm actually going to connect that on the bottom. Doesn't matter because these are connected right with that bus bar right there. So what we're going to do is connect the space heater to the other one. And this bus bar will essentially feed that power through. And we'll also connect the neutral. Like that. And we're also going to jumper the neutral over to the other outlet. And in case you're wondering, I do have to modify these. These are meant for solid core wire, potentially up to 1 on each side of the little nub, but we don't want the nub because we're using a fork connector. So I'm cutting them out, then using a blade to kind of flatten that out. And that way we can get that fork connector in there with a good connection. And on this side, we'll get leg 2 connected. As well as the neutral. And I'm not sure if I said this already, but this is already 10 gauge wire coming in here. So this can easily handle, the demands of that space heater and have a little bit left over for these outlets. So now we need to just punch out one of these cutouts right here. We'll feed in the wire from the space heater and make the final connections to leg 1 and leg 2, as well as the connection to ground. And pretty much the same story with this wire. We're going to use this white as red, so we need to add some shrink tubing to it. And really the only reason I'm doing this is that I do have a lot of 10 gauge wire from generator cords that don't have the required amount of conductors, which is 4, to make them safe. So I'm using some of this 3-wire cord to run these 240 only loads. There's nothing wrong with the wire gauge, it's just the colors aren't quite right. But the black, that is perfect. So let's cut that. Gonna get some more fork connectors for the red to be and the black. And we need a ring terminal for the ground. And now we need to swap out this breaker. So this is a 20 amp breaker that's in there right now, which is technically appropriate for the outlet since it's a 20 amp outlet. But the space heater actually pulls 20.8 amps. So we do need to upsize. I'm going to swap it for a 30 amp, potentially swap it out with a 25 amp at some point, which I believe is available. But I've got a 30 amp, so we'll swap that for now and circle back on this in the future. And for the last piece of the puzzle, so the 6-gauge wire, it is coming out in this direction. So I'm thinking we should attach the 50 amp outlet right about there. All right, so let's try this out. We are connected to utility power. We only have access to about 7,000 watts, but that should be enough to try everything out and just make sure everything works as expected. And so far, so good. Both the fans, they're turned on, so the modification we made is working as expected. So let's put on a 3,000 watt load. We should see about 1,500 watts on each leg, which we do, as indicated by the green right there. Let's double that to 6,000 watts. And now we should see about 3,000 watts on each leg. And yeah, that is working fine. So let's take these loads off. And according to the testers down here, we are wired correctly. So without anything turned on except the fans down on the space heaters, we're pulling 38 watts from each. Let's turn on the load bank fans. And with all the fans running, we're pulling about 109 watts. So let's pull 2,000 watts over here. And 2,000 watts over there. So we see 2,000 watts from each leg. Let's go to 4,000 watts. And yeah, we're pulling 4,000 watts from each leg. So a total of 8,000 watts. So good, everything seems to be working. Utility power sine wave looks good. And we're at about 2.4% THD. So everything is working as it should. So we'll turn both the fans off and power things down. All right, guys, and that is pretty much it. So we now have a load bank that is capable of 30 kilowatts. And I think the bigger question is, will we ever get a machine to try it out on? And of that, I am not sure. To date, 20 kilowatts is the largest I have tested. But, if I do land one that is going to challenge this load bank's capability, will the propane setup handle it? Probably not. Will the 4-gauge wire handle it? And if you ask Google, the answer is no, absolutely not. But if you ask the same question, will 4-gauge wire handle 125 amps, 30 kilowatts in a free air environment? The answer is yes. And it will do so continuously. In our case, we're only going to pull it for about 5 or 10 minutes, so likely we'll be fine. But that is something we don't need to worry about for now. You know, that is a bridge we can cross in the future. So, I hope this video helps someone. Thanks for watching.